All right, so we should be on Schoology, and I'm gonna go ahead and get started here. You should be on Schoology, like where my screen is, and we're gonna be in the scientific method wrap up. So open this. I would strongly suggest following along with me today so you can stay up to date, and you'll be halfway done with the assignment by the time class is over. So it'll be very helpful to you, so make sure you stay up with me on this. So click on the scientific method wrap up. And I'm going to go into student mode so I can view it with you. Okay, so when you get to this screen, all right, let me explain what this is real quick. So first up, we are going over the scientific method today. So with the scientific method, we are just kind of reviewing everything we talked about this week. So we talked about observations, experiments, hypothesis, conclusion, data, things like that. So that's what we're going to be covering this week. All of that stuff is going to be in this assignment. So we're going to start. We're going to go over a few of the vocab words so that we are on the same page moving forward. And then we'll have 3 different scenarios for you to try out. Now, this is, you get unlimited attempts on this, all right? So your highest score will be the one that goes in the grade book. So don't settle for a low score. So don't just try to finish this and be like, oh, well, I'm done with it, right? If you get a low score, you should go back and at least get an A because you have as many attempts to do this by the 22nd. By the end of class, I expect everybody to at least submit their first go through. So don't be sitting there not doing anything while we're here working. Everybody at the end of this class should at least submit one time and then go back and fix anything you might have missed. When you're going back and fixing the stuff you missed, if you need a refresher on any of the stuff that we talked about this week, go to our class YouTube channel and watch the video from earlier this week where we went, or for you guys, it was on last Friday where we went over the beginning of this stuff. So make sure you come up with something or watch that if you need it. All right. So go ahead and hit start new attempt and I'll walk you through the first part. All right, so you should see qualitative and quantitative pop up. And that's where we're going to start at. And let me resize my screen so that I can see everything. All right, something that's really important about today is I'm going to need your participation in chat. All right, so part of not being able to be in class in person and online and trying to recreate that is your participation. So please make sure you guys are paying attention and following along in the chat. So you don't have to talk if you don't want to, but you should at least be throwing your answers in the chat. So please, please, please make sure you are participating in class. It's very important. All right, so first up, we're going to talk about quantitative and qualitative. If you're just joining us, we're in Schoology week 3 folder of on the scientific method wrap up assignment. So go there. So qualitative and quantitative. All right, so I'm going to start with quantitative. So quantitative observations are ones that talk about quantities. And if you look closely at the beginning of this word, it has the same beginning as quantity. Quantity means how much of something. So the amount of something you're given. So this could be if I said you had a large quantity of candy, you would have a lot of candy. If you have a large quantity of shoes, you have a lot of shoes. If you look on if you ever ordered anything off Amazon and they give you that receipt, on there you'll see a abbreviation that says QT, and that means quantity, how many items were in that box. So quantitative observations are ones that talk about numbers, how much of something. So if there's a number, there's a good chance it's a quantitative observation. The other type of observation is a qualitative one. A qualitative one talks about a quality of something. So how much not how much, but like what type. That describes the qualities of something. So if you describe someone's qualities, you're saying that they are kind, or they are smart, or they are tall, or they have good style. Those things are qualities. Qualitative observations are qualities. So if you don't understand the whole word, and I understand these are big sciencey looking words, just break down half of it, and it sounds like words that you know the definition to, and that will help you answer it. So I'm going to go through and I'm going to answer a couple of these for you to kind of give you a head start, and then you guys are going to finish the rest. These might be different. So the order A and B could be different for you. So make sure that you are going with what's on your screen, going with what you say instead of what's on my screen, because yours might be different. All right, so first one, the cup had a mass of 454 grams. 454 grams is a number, all right? And numbers talk about quantities. So that is a quantitative observation. So I'm going to put B here. That might be different for you, but I'm going to put B here because 454 grams is talking about a quantity of grams, and that's a quantitative observation. The temperature outside is 75 degrees. All right, again, we have a number, so that is a quantitative observation. It's talking about a specific amount of degrees. So that's quantitative. It is warm outside. All right, it is warm. Warm is relative. It's talking about a quality of the weather. All right, we're not talking about, if I wanted to say it was warm in a quantitative way, I would say it like I did for number 2. I would give you a number. But it is warm outside is a qualitative observation. Does anyone have any questions? You go ahead and throw it in the chat, and I can try to clear it anything up for you if you need it. Okay. All right, so go ahead and do these on your own. When you're done with the highlighted questions, put done in the chat. And then I'll know to move on to number 2. All right? So I'll give you guys a few minutes to do that. And when you're done, put done in the chat. So we have 13 people in the meeting, and with those 13 people, I'm going to look for about half of them to be done before I move on. So that means we need like 6 or 7 people done. So right now I have 1, 2, 3, 4, 5, 6, 7 people done. And that's how I'm going to know when to move on, when around half of them are telling me they're done. Okay. All right, so part 2, we're going to talk about these vocabulary words, and we're going to try to match them to their definitions over here. All right, we talked about all of these during the week, and we use them interchangeably. To make sure that when we do this, we're going slow and making sure we read this entire piece over here. So number 1, a part of experiment that is not being tested and is used for comparison. This is the key word, is comparison. So what are we comparing our results to? So this is the part, I'm also going to reference the two main experiments we talked about, the one with the brownies and the one with the candle. So in the brownies, we compared the containers with the bread to the containers without the bread. So the container without the bread was the comparison container. In the candle lab, the jar that was under regular circumstances with just the regular pan, it's purple water in the jar, that's what we compared everything else to. So when we compare something, we are using the control for that. All right, your order over here might be different. Okay, so if I put my control is option D. So it might be different for yours. So make sure you are paying attention to your screen and putting in the letter that matches for your exercise. Mine might be different, but as long as you have the word right. So the control is something that we keep the same. If we don't have the control, then we don't know how much something changed. And that's really important, because then if you change both of the experiments, then how are you going to know how big of a difference there is between what's regular and what you did? So for example, say we put with the brownies, say you put a piece of bread in one and then you put an egg in the other one. Say they both came out tasting fresh. All right, how are you going to know if it's any different from where you started? Does that make sense? So the control is the one that you start with, the one you don't change, and you compare what you change with to the control. I saw a few people just joined. If you're just joining us, we are on Schoology in the week 3 folder, and we're working on the scientific method wrap-up assignment right now. So go there and open it up, and then go to where we're at and follow along with us. All right, part 2. Any part of the experiment that has change, that can change. All right, now, any part is key. It's not just one specific thing, it's any part of the experiment. So we have dependent variable, independent variable, and variable. They all have the word variable in them, so you know it's a variable. But any part is specific to the word variable. All right, so the dependent and independent variable can change, whereas you could change the independent variable like we did with the jars and the amount of flame in the jar for the experiment, and you can change, and the dependent variable can change too. So for us, that was the amount of water that also changed. So any part of the experiment that can change is the variable. Okay, so 3, the part of the experiment that is changed by the scientist or person doing the experiment. So what part of the experiment, is it the independent or dependent variable, is the thing that we as scientists change? Go ahead and put that in the chat. Which one is the thing that we change, we have control over, the independent variable or the dependent variable? All right, I got 3, 4, excellent. Good participation, guys. All right, you got it right. It is the independent variable. All right, the independent variable is the, oops, that's wrong, is the one that we change. So we change the independent variable. So we change the size of the jar. we changed the amount of water, the size of the pan, and the amount of flame, okay? It's not dependent because the dependent variable changes based on the independent variable. So for us, we're looking, the dependent variable is something we don't have control over the change. It's if you think about it, it's the key thing we're looking for. We're looking for the change, and we don't want to have anything to do with that. So we can change the independent variable, like in the brownie situation where we put the bread in the container, but we can't control how fresh it is. And that's the thing that we're looking to measure. So it's the part of the experiment that you're measuring and is affected by the independent variable is the dependent variable. The independent variable is the thing that you are looking to see if it has an effect. So it's the part of the experiment that you, the scientist, get to change. All right. Pretty good so far, guys. Good participation. I appreciate it. You guys are doing exactly what you should be doing, so keep up the good work. All right, so next up, we are going to be doing a few different scenarios. So I'm going to walk you through this one, and then you're going to do the other two on your own. So there's 3 total, and they're all SpongeBob themed. All right, so here I'm going to have a scenario for you. It's going to be something that has everything a scientific experiment should have, and then you're going to answer 4, let's see, 1, 2, 3, 4 questions about each one. It's going to be this is going to be the same setup for everyone. What's the control? What's the independent? What's the dependent? And then what should your conclusion be from that stuff? All right, so I'm going to go ahead and start with this one. Mr. Krabs created a secret ingredient for breath mints that he thinks will cure bad breath people get from eating Krabby Patties. He asked 100 customers with a history of bad breath to try his new breath mint. He had 50 customers eat a special breath mint after they finished eating Krabby Patty. The other 50, Group B, also received a regular breath mint after they finished the sandwich. However, it was just a regular breath mint and did not have the secret ingredient. So Group A has a secret ingredient. Group B does not. So Group B is just a regular breath mint. Both groups were told that they had bad breath, that they would be getting a cure for that. So both groups were told that they were getting a breath mint that would cure their bad breath. So this is important because this eliminates what's called bias. Bias is an unconscious, something you just do that favors a specific way or behavior. And it's not something you do intentionally. All right. So if anyone ever heard of a placebo, put in the chat. Have you heard of the word placebo? Yes or no? Okay. So when we do scientific experiments, one group that's the control group gets the placebo. So the control group gets the placebo because they're going to be comparing the results of the group that gets the treatment or the drug to the results of the placebo, the people that didn't. And the reason is because sometimes people, when they get something that they understand what if the treatment is supposed to help, sometimes it'll affect how they behave without them realizing it. Here's what I mean. So if I was selling a pill that I'm like, it increases your memory, you'll do so much better in school and you'll never forget a password and you'll remember everything. So try this pill. And I wanted to prove to people so I could advertise that it worked. So I would conduct a study. If I conducted a study and I gave half the people the pill that I'm actually trying to test, and then I gave the other people a M&M. And they look the same. Sometimes people that get the M&M and think it's a real pill will start to act different throughout the week because they think that they're getting the real pill that will help their memory. So they might just subconsciously, without trying, just pay attention a little bit more, or write things down, or just focus a little bit harder on things that they normally wouldn't, because they're like, man, I'm taking this new drug and it's helping me so much and I can remember so much more, when in reality they got an M&M. So people can change their behavior unintentionally during scientific tests like this, and it'll mess up the results if they tell them what's going on, or they don't tell them what they got. So how many of you guys have ever an easier one to think about is, how many of you guys have ever seen Space Jam? Have you guys seen Space Jam? Please say yes. Please say yes. Okay, thank God. I had some people in my other classes that hadn't seen it, and I was really skeptical of their childhood and what they were doing with their life. So yeah, all right. So you guys remember in Space Jam how at halftime, when they're getting beat up by the Monstars, how Bugs Bunny puts the label on the water bottle and he hands it around everybody and says, like, this is the secret sauce, this is the secret juice, you'll play so much better if you drink this. And then everyone drinks it, and then they all like have like a crazy reaction to it, and they go out and they play super good. All right, but it's actually just water. It was just water. So that's like a quick example of like what we mean. Like when you get something that you think will have an effect on you, you might subconsciously feed into that. So that's why in this example, you have to tell both groups that they're getting a regular mint. Okay? So that way it won't skew their results. All right, so then 2 hours after eating the Krabby Patties, group A had 30 customers in group A and 10 customers in group B reported having better breath. So remember that group A had 30 customers. Group B had 10 customers that did better. Now don't look at the number, look at the percent. So 30 out of the 50 in the group, and then 10 out of the 50 in the group. So think about that. All right, number one. Which group was the control group? Put A or B in the chat. Group A or group B? Which one is the control group? Oh boy. Okay. Remember, the control is the group that has the regular mint. It's what you compare to. All right, there we go. There's that change. So we are comparing the group that has the special breath mint to the group that has the regular breath mint. So that we should see a change in A, and we can compare that change to the regular breath mint. So group B is the control group. They're the comparison group. All right, so I hope that cleared that up, because we were on the wrong path beforehand. All right, next up, the independent variable. What is the thing that Mr. Krabs is changing? What's the thing that he changed about the mint? Was it the mint, the ingredient, how many Krabby Patties, or the Krabby Patty ingredients themselves? Good. Good. All right, much better. He changed the special ingredient. So he added an ingredient to the mint to, spice it up, make it better. So that's what he's looking to change. He's looking to see the results from that and compare it to the regular group B that got it. So if they got better results, then you can imply that they came from the secret ingredient. Now, what is the secret? What is the whole point of this experiment? What are we trying to measure here? What are we looking for to see if there is a difference? The freshness of breath, number of mints, number of Krabby Patties, or the ingredients in the mint? What are we looking to change? Good, guys. All right. Yep, the breath. All right. We're looking to change the freshness in the breath. So we are hoping that by adding an ingredient, we can increase the freshness in the breath. Very good. All right, so now we got to talk about conclusion, and this requires some brain power, okay? So we got to think. Look at your data. Your data here would be this part, the 30 customers in group A and then 10 customers in group B. So remember, you had 50 customers in each group. 30 out of the 50 said their breath got better in group A. Only 10 out of the 50 in group B said their breath got better. So think about that. All right, the breath mint with the secret ingredient does not reduce breath odor. Is that true or false? Does not reduce breath odor. Okay, because we clearly saw people say, yeah, my breath smells better. All right, it's false. So it can't be this one. Now again, this might be a different order for you than I have, okay? So I'm just eliminating the answers as we go. All right, so the breath mint with the secret ingredient reduces breath odor by over 80% of the time. All right, so how can we figure out what percent of the time the breath odor was better or worse? So remember, we have in group A is 30 out of the 50 customers. In group B, it's 10 out of the 50 customers. So then what percentage of A had better breath? On what percent? I kind of gave you a hint in the chat. What's 30 divided by 50? Good, Terrence. 30 divided by 50 is 60. So that's 60% of the participants in group A had better breath. What about 10 divided by 50? What's 10 divided by 50? 10 divided by 50. There you go. All right, guys. If you type in a calculator, I should be seeing decimals here, unless you're talking about percents. So 10 divided by 50 gives me 0.2. But if you said 20, I think I understand what you're trying to say. You're trying to say 20%. Okay? So 0.2 is equal to 20%. So in group A, they had a success rate of 60%. And group B, they had a success rate of 20%. So neither of those is the 80% that this question talks about. So it cannot be B. Saying neither of them worked at all is gotta be false because you had people in both groups claiming that it worked. So it cannot be C. So the answer's gotta be D because the secret ingredient had a better success rate than the regular breath mint. And that's what we just talked about here. So the success rate of group A is 60%. 60% of the people said that it worked. And in group B, 20% said it worked. So it did have a better success rate than the regular breath mint. All right, any questions on these ones before we move forward? Okay. Again, thank you guys for the responses. All right, you guys are doing a good job participating. I like what I'm seeing. It's good stuff. All right, so I'm gonna let you guys do this one on your own. I'm gonna kick it off for you. I'll read it for you, and then let you guys answer these questions. So SpongeBob noticed that his favorite pants were not as clean as they used to be. His friend Sandy told him that he should try using Clean O detergent, a laundry soap found at the Sale Mart. SpongeBob made sure to wash one pair of pants in plain water and another pair with the Clean O detergent. After washing both pairs a total of 3 times, the pants washed with the Clean O detergent did not appear to be any cleaner than the pants washed in plain water. So, what was the problem they're trying to investigate? So basically, what is the hypothesis? Independent, dependent, and then what should the conclusion be? When you were done with this problem set, when you finish number 10, throw done in the chat, so that way I'll know when to move on. I'm gonna come back for sure at 10:45 because I wanna walk you through the last one and kind of explain, there's a data table and I wanna make sure you guys understand how to read it before I let you loose on that one. So go ahead and do these questions 7 through 10, and I will be back in 7-8 minutes to do the wrap up. When you're done, put done in the chat. If I get a lot of people, I'll move on before then. All right, guys, it is 10:45, so I'm gonna come in and we're gonna wrap this up. All right, so this one is the last one. Some of you guys have already moved on to it, but the thing I want you to look at is after you read this, there's a chart that shows the diameter of each bubble that they blew. Now remember, the diameter is the distance across a circle. So it's how big the bubble is. And you have your super bubble diameters over here and your regular soap bubbles over here. Now, when you look at this chart is important for question 14. What should their conclusion be? So when they ask about the conclusion, you need to think about, one, what claim did super bubble make? So what did they claim that they could do? Like, what is their hypothesis being, if you use super bubble, then what will happen? And then you look at and just kind of just do a spot comparison, just a real quick, all right, so how does this compare to this? And go make your way down and see if their claim is true. Now, think about overall. The claim is that double bubble or super bubble can do double regular soap. Now, there are a few instances where that's true, but I want you to tell me about the overall trend. Would you be happy or satisfied or sold by the super bubble marketing where they said, we can do double the size? All right, would you be happy with that or not? Do you think their claim held up or not? And that is what you answer here. So if you are done with this, that's all I got for you today. I want you guys to remember to give this as many tries as you can to make sure you get a good grade on it. You shouldn't settle for anything less than an A. All right, and that's why I gave you till Tuesday to work on it. On Tuesday, we're going to be starting with atoms. We're going to really get into chemistry and start, the real science. But I thought this was important to cover prior to, so that when I use this information, this language, you understand what I'm talking about. So again, great work today, guys. I hope you have a good weekend, and I will see you on Tuesday. If you have any questions, feel free to hang out in the chat or come see me during my office hours. My office hours today are from 11 to 11:50 or from 2 to 3 p.m. All right, so I will see you guys later and have a good weekend.